All right, so here we go. Quadratic functions and their graphs. So gets to be pretty fun here. We get to start graphing, and here we go. So the equation for the line of symmetry. So if we have a graph, just a small sketch. Here's a possible quadratic function. It's a parabola, just in case you forget. And it's got a few different things going on. It's got the axis of symmetry, which goes right down the middle. At the either minimum or maximum of the graph, depending on where it's at, you've got the vertex. And the vertex, the x value of it, is your axis of symmetry. Once you have that x value, you would plug it back into the equation to find out what your y value is. Some other things you have on your graph will be your x-intercepts. The x-intercepts are also called roots or solutions. And this one I didn't draw it very in a useful way, I guess, right here. But where your parabola hits the y-axis, you'd also have your y-intercepts. So that's just kind of what we're talking about right now. So your equation for the line of symmetry, when it is in standard form, when it's in standard form or general form, you'd hear that. That is your ax squared plus bx plus c equals y. And when it's in this form, your equation for the line of symmetry is going to be that x is equal to negative b over 2a. Now, if you've seen some of the other videos, you've seen that I break the quadratic formula up into this part right here, negative b over 2a, and then plus or minus the square root of b squared over 4c, or b squared minus 4ac, also over 2a. And the reason is that I want you guys to memorize fewer things rather than having to memorize more and more. And right inside that quadratic formula, which you already know, is your equation for the line of symmetry. There it is. So negative b over 2a. You got two methods to finding the vertex. One is find the x value if it's in standard form again. Find the x value of the or find the equation of the line of symmetry, and that x value, you're going to plug it back into the equation. So find the x value using negative b over 2a, x equals, and plug that back into the equation and solve for y. Plug x back into the equation and solve for y. That's one method. Another method is going to be to find your x-intercepts. So here's method one, here's method two, find the x-intercepts. All right, once you've found those x-intercepts, remember that axis of symmetry. So if we have our two x-intercepts here, that axis of symmetry has to be right in the middle. So the x value of the vertex is in the middle of those x-intercepts, or of those roots, of those solutions. All right. Now to find your y-intercepts, and this is not specific only to quadratic functions, this is for any type of graph that you will ever have. How do you find your y-intercepts? Well, you plug in 0 for x. Plug in 0 for x, then solve for y. And that's, again, true for any equation that you can have. It doesn't matter what type of function it is. If you plug in 0 for x, that's going to be right on your y-axis. And then whatever you get as y is where you would be hitting the y-axis. That would be your y-intercept. And very similarly, how do you find your x-intercepts? Well, you plug in 0 for y. then solve for x. Solve for x. And that makes sense, just like we did with the y-intercept a moment ago. If you have a y value of 0, it doesn't go up or down at all, but it's wherever you end up being with x, that is your x-intercept. I hope that helped.